In this video, we're going to talk about how we name covalent compounds. Now, before we go into the specifics about naming, we need to first cover or review electronegativity. Now, you might remember electronegativity is the ability of an atom to want electrons, and the electronegativity values are all relative. So we need to look at a periodic table to determine relative values of electronegativity. So if we remember, the element fluorine has the highest electronegativity. Fluorine really wants electrons, and so therefore fluorine has the highest electronegativity value, whereas elements like cesium and francium have the lowest electronegativity. Now, electronegativity increases as you go up the periodic table and increases as you go to the right. So basically, whenever we're dealing with covalent compounds, we're only dealing with the nonmetals. So remember, there's a stair-step line that distinguishes the nonmetals from the metals. And so these over here are the nonmetals. And whenever we're naming and writing formulas for covalent compounds, we always write the element with the lowest electronegativity first and the one with the highest electronegativity last. So for example, if a compound had fluorine in it, fluorine would always be the last element listed and also named. So keep that in mind whenever we're writing formulas for electronegativity or for covalent compounds. Now, how do we name covalent compounds? So remember, covalent compounds are only between two nonmetals, and because of that, these combinations can be numerous, and so we have to use special rules to determine what the name is for covalent compounds. To do that, we use what we call the Greek prefixes. And so if you remember your polygon shapes, you remember your Greek prefixes. The Greek prefixes that you have to know for naming covalent compounds include mono for 1, di for 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa is 8, nona is 9, and deca is 10. And so we will use these prefixes to help us determine or to write the formulas and the names for the covalent compounds. Now let's do an example. P2Cl6 is our first example. This is a nonmetal, so this is a covalent compound. Phosphorus, chlorine, they're both nonmetals. They're to the right on the stair-step line. We have 2 phosphorus and 6 chlorine. So we will use the Greek prefix for 2, which is di, and the Greek prefix for 6, which is hexa. And so the name would be diphosphorus. Whenever we write the name for the first element, we just simply write the name of the element, including whatever Greek prefix. And then for the second element, we use the root name, just like we do for ionic compounds. So in this case, it's chlor. But first we need to put the prefix 6, which is hexa. So it'll be hexa. And then we do chlor for the chlorine, and then we end it in IDE. Every binary compound that we write, including ionic, it always ends in IDE. And so the name for this is diphosphorus hexachloride. Now there are some special cases. One is whenever we use the Greek prefix for 1, mono. We never use mono for the first element, but always for the second element. And another thing, we hardly ever write 2 vowels together whenever we're including the prefix. And that is mostly for whenever we're dealing with oxygen. So for example, if we had the Greek prefix penta and we had to add oxygen, we would write pentoxide, not pentaoxide. So we would drop the A in that case. Let's do one more example. One that you are more familiar with is CO2. So again, we list the name of the first element, which is carbon. There's only one carbon, but since it's the first element, we do not use mono. And then we have 2 oxygens, so it's di, and then oxide, ending in IDE. Now let's go the other way. Let's say I give you the name dinitrogen pentoxide. Dinitrogen pentoxide. Again, remember we're dropping the A because we combine A and O, and we always drop the vowel for the Greek prefix whenever we're dealing with oxygen. So dinitrogen, di corresponds to 2. So we have 2 nitrogens. And then penta is 5. So it would be N2O5 is the formula for dinitrogen pentoxide.